you would be trying out firstly the same example on your own, and then, besides that, whatever else that you want to try out, any permutations you want to try out, any combinations, you try that out with that on your own. Okay. In addition to that, I will be giving you some short assignments at the end of every session, which you need to do, right? My experience with a lot of previous CDAC batches is that sometimes you tend to do that assignment in groups. Now, I don't like that. I don't like what you do there, because then what happens in the group, there's one person coding and the other persons are just following him or her. So that, that one person is getting his work done, and that one person are happy with that, but the others don't gain that much. So I would prefer it if you do the assignment on your own, individually, without any other help. Because ultimately, that is how it's going to be. No? You're not going to be coding in a group. You're going to be coding individually. So that is what you need to do. Yes, after trying it, let's say you give it a good try. Let's say you've tried 3-4 hours to do that, and you're totally stuck and you don't know what to do, or if you're just not able to get it, then maybe you could ask someone for help. But your first option should not be, let's do it in the group. First option, do it on your own. Then as a backup, if you cannot do it, then yes, then you can ask for help from either your friends or people in the lab would be there to help you out. So you can ask them, okay, I'm stuck on this. I'm not able to do this. What should I do? And that too, don't get the whole solution from your friend. Let your friend tell you what is the next step. So if you cross that step, then yes, then try the next thing on your own. So if you're friends, then you should not be giving the solution to the person. You explain to them, okay, this is what you need to do next. This is where you're stuck. This is how this is why your code is not working. But don't give him the solution. Solution he has to find on his own. Okay. Third thing, and this is something that I'm sure has been told to you a lot. Earlier batches, even with CDAC, Khargar and Juhu, I would be there for the lab. But this year, this batch, I'm not able to come in for the lab. So generally, what I found is that a lot of people are discussing concepts in languages other than English. Marathi being the most common one, Hindi being the second most common one. So you're talking about that topic in other than English, everything else. So don't do that. And there's a reason why I'm telling you not to do that. The reason is that sometimes you know the concept, but you find it very difficult to express yourself in English, right? So for example, if you're used to talking only in Marathi or Hindi, then naturally you start thinking only in Marathi and Hindi. And when you go in for an interview, or if you're, let's take even one stage ahead of the interview. Let's say you're talking to a client and the client doesn't understand your Marathi or Hindi, for example. Then how are you going to communicate to the client? You need to be able to, have that technical communication should be in there. I can understand if you talk to each other in Marathi, to ask काय जेवलास किंवा आज सरांनी खूप कठीण हे केलं, whatever, that you can talk in Marathi. But the example itself, how can you explain to the other person in Marathi, or how can you discuss that in Marathi? So that is not okay. Okay. So I don't know what is this thing. Aniket, what happens here? Is it majorly Marathi and Hindi, or in English also? Is Aniket here?
Yes, sir. Yes, sir. Yeah, students can speak in English, sir.
Can they? What do they right now? What is the major? What have you noticed? What do they generally speak in?
They are speaking in currently Hindi, sir. They are preferring Hindi.
Hindi and Marathi. So that is a big no-no.
Yes, sir.
You all have your interviews coming up shortly. The person who goes to you is from Chennai. He's come from Chennai for this thing. He'll not understand Hindi. What will you talk then? So you can't be doing this. I know this because I've just come in from CDAC Pune yesterday. I just finished CDAC Pune late yesterday. I finished that. And same problem there. The person finds it difficult. The person, he's very good technically. I can see his code and I know he's very good technically. but 3 sentences he's not able to talk in English. So do you want that to happen to you, where where you're very good technically, but you're being rejected because you can't communicate? Okay, or forget that, you're taken on a job, let's say you are got an opportunity to fly to the US or UK, your client. Your project manager says, no, this person is very good, but he will not be able to talk to the client there. So I'm not sending him, I'm sending somebody else. So don't do that. Don't let that happen to you. Okay, it's a very serious issue. I'm sure Dr. Johnson would have addressed this and, spoken to you multiple times over, but you all unfortunately don't take it seriously enough. So now you don't have enough time. This is the last module, and then your projects and then your interviews. So get into the habit of speaking technical stuff in English. And if your friend is speaking in a language other than that, please stop him from talking and say, please speak to me in English. So help yourself and help your friend also. Please do that, right? Very, very important. All right. Other than that, yeah, I mean, everything else, these are basic instructions that I wanted to share with you all. Other than that, in the training itself, in the lecture itself, if you have a doubt, please feel free to ask me. Okay, keep your videos on. A lot of your videos are off. Keep your videos on, right? There's no reason for you to keep your video off. The only reason why you would want to keep your video off is if you're having a poor connection. If you're having a poor network and you cannot keep your video on, then that is a different thing. That I understand. Is you just can't connect. You're in a poor network connectivity issue. So first thing, get your network thing sorted out. But if that is not, then keep your videos on. When you keep your videos on, 2 things happen. 2 good things happen. First is you are at your attentive best because you know you're on screen. First thing. And second thing, I also get a feedback from you all. In the sense, I can look at your face and I know whether you're following me or not. Otherwise, if I'm looking at a blank screen, I have no idea what is happening. So even your body language, your face, your gestures, they convey to the trainer that yes, we are following, not following. The trainer can then adjust his pace accordingly. So keep your videos on, first thing, very important. Second thing is, if you have a query or question, feel free to stop me at any point of time. Ask me during the session. I encourage that. I like that. That means you are participating. We are here all to learn. We don't know the topic already and come here. That has not happened. We are all here to learn. So any question is okay. Even if you feel it's a stupid question, how can I ask that? It's so simple. How can I ask that? Don't feel that, because like you, there might be 20 others who are having the same question in mind. So don't feel scared to ask questions. Don't feel scared to communicate. All right. I encourage that. I like that a lot. If you're asking questions, have a conversation with me. Ideally, we should have been in the same room, right? We ideally, if the batch is not online, we should have been in the same room, and that would have been more effective. But if that is not happening, then the second best thing is you communicating with me. That is very important. I still see a lot of videos are off. I don't know why you all didn't understand me the first time now. So if you all are not having a good connection, then that's okay. But otherwise, please keep your videos on. All right. All right. Okay. Okay. Now that we are given a few instructions about that, a quick word about me. All right. My name is Vikram Sulakhe. You can see that actually in the screen. But I'm here for the .NET module. We know that as well. And I've been sort of associated with a lot of CDAX centers for a very long time, over now 25 years of association with them. I mainly do corporate trainings. I do a lot of corporate trainings, and sometimes I meet some of you all in a corporate training batch and say, "Sir, Larry, you're here." And like in an online session, I may not recognize you. In person, if I've taken the session, I can actually sort of remember some faces. So yeah, I do mainly corporate trainings and consultancy work. And my expertise level is mainly in .NET. I've been working with .NET for a very long time. Ever since the beta copies of .NET have come out, I've been sort of associated with .NET. And I like training a lot, so which is why I'm in training. I like interacting with y'all. So the pandemic in between causes a situation where we're doing these online trainings. I hate online trainings. So which is why I say that, if you can interact, that is a better way of working. Right. Anyway, so let's get started. Any questions that you have for me before we start?
So what would be the approach for this module?
From my side or from your side? What?
No, from our side, how we can approach it?
Okay, so what I'd be doing is, I believe that, if you're a good programmer, if you can write good code, then you also understand the concept easily and you can answer any technical questions on that. That is my belief, right? So my focus is going to be majorly on coding. Over 90% of what I'm going to do is through code. And then in certain cases, yes, then we can, when we need to have a theoretical discussion, then I will have that. But my major approach would be on code. And I suggest, you follow the same thing. So as I said, I'll be taking one coding example here in the class. Let's say, for example, I'm doing inheritance. So I would be taking an example on inheritance in the session that I am with you. When you go into the lab, you have to first try out that same example. Because here you're just seeing it. You're not able to code with me. Because I'll be going at a much faster pace. So it will be impossible for you to keep in pace with me. There might be certain sessions where I will tell you that, okay, do this with me out here. But majority of the time, I'll be showing the session and going at a quick pace. So you will not get time then. So first thing that you do in your lab time is you complete the example that we have done in class. When you're doing that example, I will be sharing my code with you. You don't have to copy paste the code, right? You can look at my code, but you have to write the code yourself. So you have to, every line of code that I have, you have to write it down. There's no copy paste that you need to do out there. After you finish trying that example, there will be, obviously questions in your mind of, hey, what if I did this instead of this? What if I tried doing this? What if, I'm doing things like Vikram is doing things in a certain way. What if I try doing it in a different way? Will it work? Will it not work? So do try out that. That will help you gain confidence on the code. After finishing off all of that, there will be an assignment that will be based on the topics that we have. Finish the assignment. And then later, whatever other time that you would have during the day, read up on topics that we have covered in the given day. Okay. The ebook that I've given is one source of information. Other articles, other things that you need to have, use those as well. So that is the approach that I would recommend that you use. All right. I just saw that the session is being recorded. Okay. And the recording may or may not be available to you. I don't know what is the situation. But one thing that I discourage is, and this has happened in previous batches, so which is why I say this. Is like supposing I've taken a lecture from whatever, 10 to 12, I've taken a lecture. Now, what I find happening is that some people are there in the lecture with me, and then after the lecture ends, they again look at my lecture again, all over again, which I find a waste of time. Now, firstly, I'm flattered that you want to see me again. Okay, but that's besides the point. You should not be wasting your time in looking at the lecture again. Whole lecture. I mean, 2 hours again. It's a waste of time. I can understand if there is a certain section that you have not understood. Okay, 5 minutes of the session I didn't understand. Maybe my connection was weak. Maybe somebody else came. I could not understand whatever. I can understand 5-10 minutes to look. But you can't be wasting your time in revisiting the lecture again. Somebody told me once, sir, after your lecture ends, 3 times I see your lecture. 3 times? 6 hours that person looking at me. I can't look at myself in the mirror for that much time. 6 hours the person is looking at me. Waste of time. Do not do that. Certain section you're not understood. You want to listen to it again. That is okay. Certain section only. I'm saying 5 minutes, 10 minutes max. Or maybe if there's a UI option, which says that, okay, first click here, then click here, then click here, then click here, then click here. So you may not remember the sequence of events. that section you want to look at again, that is okay. But please do not go over the whole lecture again here. You have to try things on your own. You don't have enough time in the day to do that. I can understand if we did one session today, 2-hour session today, and then after 3 days we had one more session. So now you're bored. What do you want to do? Chalo, we'll look in the session again tomorrow. But that's not happening. We're having 3.5 hours in the day. So do not waste your time in re-looking at the whole lecture all over. Okay. Yeah. Any other queries or questions before we jump into the code, so to say? Not code, but jump into the session.
Thank you so much, sir, for addressing.
Yeah. Okay. Okay, let me share my screen and let's start off. Screen visible?
Yes, sir.
Okay. So let's have a look at, what. Okay, before we jump into any code, we'll be looking at an introduction to what is .NET all about, understanding a few key concepts, few key terminology, and that will help us while we are coding. Okay. So let's start with, any software application that you have to create. You typically create a front end, you create a middle tier, and then you have the database layer. Now, before .NET came in, before we were using .NET, what was the scenario that we had then? So typically you would have front end which you would create using either VC++ or VB. I'm talking about Microsoft, okay, Microsoft products. So for your front end, you would use VC++ or VB6 for creating desktop-based applications. And if you had to create any web-based applications, you had something called as ASP, right? Then to write code in the middle tier, you use something called as the component object model or COM. Actually, one more thing, keep a notebook and pen ready with you. Take down any notes that you need to as the session goes on. Okay, like a regular class, you would normally take that notes. Keep a paper and pen ready with you. So we had something called as the component object model or COM, which allowed us to write the middle tier, right? Now, what would go into the middle tier typically? Yes, typically what goes in.
Establishes connection between front end and database.
Right, correct. So basically your, what is known as business logic and all other code would go in there. Validation code would go in there. So validation code here in the middle tier was being created with the help of COM components. So this was a scenario before .NET came in. Now, there was an issue with all of these components. For example, VB6 did not support object-oriented code and didn't support threading. So two important aspects when you're writing any software, okay, was not supported in VB6. But VB6 was very easy to use, very simple to use. Now, these features that you had of object-oriented code and threading were supported in VC++. But VC++ was very, very complex to use, extremely complex code. Okay. The other option that you had, when we talked about was ASP. ASP was used to create web-based applications, and ASP was script-based, interpreted code, late-bound code, difficult to maintain and debug, not object-oriented. So a lot of problems with ASP as well, right? Now, these were the problems in your front ends, but the biggest problem lay in the middle tier, in the COM component. And when you create a COM component, it actually physically, see, COM is a concept or a theory, but the physical implementation of COM component would be using something called as an ActiveX DLL. And this ActiveX DLL gave you a lot of problems. So typically these problems were called as DLL hell, the problems that you face with ActiveX DLLs. So the major problems that you had in ActiveX DLLs were versioning and deployment. Now, I'm not going to go much into how ActiveX DLLs work, because that's not our focus. But any ActiveX DLL had to be registered on your system by making some entries in the registry. And the way in which it was structured, sometimes versioning would be a problem, right? Deployment was always an issue. So there were a lot of issues that developers faced with ActiveX DLLs. Okay. So there was a crying need. There was, Microsoft had to address all these issues. And they said, instead of addressing all these issues individually, instead of trying to fix problems in VC++ individually, instead of trying to fix problems in VB6 individually, instead of trying to fix how COM works individually, we will come up with an entirely new environment, entirely new framework, which addresses all these issues and also provides other features. And that was the birth of the .NET framework. The major reason why .NET framework came up was all these issues that were there earlier. Where now they said, now we're going to write code entirely differently from what we wrote earlier, and create applications in the .NET framework. So what was, besides addressing these problems, what are some of the problems that .NET allowed you to have? You had, firstly, everything that you wrote was object-oriented code. .NET supported multiple languages. So .NET, for example, you can write .NET code in over 50 programming languages. So if you're coming in from, let's say, a C++ background, now the logical choice then would be to write code in, let's say, C#. Or if you're coming in from a VB6 background, then the logical choice would be to write code using something called VB.NET. Or there are so many other .NET languages, like, there is a COBOL.NET for mainframe programmers, or Python.NET, or whatever. There's a Java.NET also. There is a, Fortran.NET, you name it. And there are, multiple .NET languages that are supported out here. Okay. .NET allows you to write code for multiple platforms as well. But I have put an asterisk next to it. So what does that asterisk indicate?
The terms and conditions are applied.
Terms and conditions applied. So, we'll talk about what terms and conditions and, in what situation, what would be used as we go along in the session. Okay. Then you can create multiple project types. Web-based projects, desktop-based projects, services, mobile applications, multiple different types of projects that can be created out here in .NET. In the course, however, we are not going to do all of them. We're going to look at mainly ASP.NET and MVC core. So we'll be focusing on one type of application here in .NET. Then you have much better security features in .NET and a lot of improved performance. So this is a major sort of advantage, that all .NET code that you write is giving you a lot of performance enhancements as compared to not just previous Microsoft code, but also its closest competitors. So for example, .NET code runs more efficiently and much faster and better than even Java or any other language package that you talked about. It outscores that very easily. So you have plenty of features besides the problems that were there. Those areas have been addressed, but a lot of other features that are there in .NET code itself. Right. When you work with .NET, you'll hear different terminology. You'll hear things like .NET Framework, .NET Core, .NET. So let's try and understand a few of these terms. And let's first talk about what is the .NET Framework. So I'm now specifically discussing what is the .NET Framework, and then we'll introduce more terms as we go along. Okay. So typically a .NET Framework is like a layer. It's like a platform that is installed on top of your operating system. Right? Whatever your operating system, your .NET Framework sits on top of that. And the .NET framework internally will make calls to your operating system, which of course internally will manipulate the hardware that you have out. Okay. So that's your .NET framework, which is like a layer on the operating system. Okay. Now, if you have to write any code in the .NET framework, first thing is you can create a variety of different applications that you can choose to write code for. Like for example, you could create web applications, you could create desktop-based applications, which are called as Windows Forms applications, console applications, web services, something called as WCF or Windows Communication Foundation. Right? I'm not explaining all of these because that's beyond the scope of what we are talking about, but variety of applications, Windows Presentation Foundation, workflows, ASP.NET MVC, then .NET Core applications you can create. Xamarin deals with your mobile networking. You can create applications in that. You can create Windows services, web APIs. These are just a few of the options that we have chosen, the more popular ones. But you can create multiple different applications out here. Right? Now, depending on whatever application you're creating, you'd still need to use the code from the .NET base class libraries. Any code that you're calling will all be present in these .NET base class libraries. And these .NET base class libraries are present in the form of what are known as assemblies. Right? Would have an extension of DLL, but these are called as assemblies. So each individual, library is an assembly. An assembly is a unit of compiled code. Whatever code that you're writing, if you compile it, on compilation, you're getting an assembly. So I've just listed out just 3 of them. I mean, there are hundreds of these, but a lot of the data, all the methods and classes that you're using are present in system, system.data.dll, system.xml.dll, and so on and so forth. Multiple classes that are present out.
Sir,
Yes.
so is this net-based class library similar to packages in Java?
Yeah. So an assembly would be an example of a package. If whatever you're calling a package in Java would be called an assembly in .NET. Who asked the question? Akash?
Yes.
Akash, I can't see you though. I can see a...
So I have a issue with the net connection. If I turn on my camera, I'll be off from the lecture itself.
Okay, fine. Okay, then I'll just look at your smiling foot.
Thanks.
Okay. So we have the .NET base class libraries out here, and all your applications would be using these. Okay. So supposing you're writing some code, let's say you start off with writing some source code. We have said that you can code in any .NET language. Okay. The language that we are using out here for our training and for the CDAC module is going to be in C#. But you could code any of these applications in any of the .NET languages. Right? Another example that I've given here is VB.NET. VB.NET is another, probably C# is the most popular one, but VB.NET is probably the second most popular .NET language that is available out there. On compilation of your code, the code that you're writing is in the source code format. On compilation of your code, first thing, the compiler that you would use would be dependent on what language you're coding in. So C#, for example, will use the C# compiler. Right? The C# compiler is a command line utility which you can use CSC, for example. Okay. Or VB.NET would use VBC. Right? VB compiler, for example, so on and so forth. Each language would have its own compiler. Now, irrespective of what language you code in, what compilation you do, after compiling it, you get an assembly, right? So the same assembly that we talked about earlier, you get an assembly. What is an assembly? An assembly is a unit of compiled code. On compilation of your code, you're getting an assembly. And this assembly is, I'll use a term that you're familiar with so far, is in bytecode format. Okay. But here, the bytecode that we are using in .NET has a name. So the bytecode is called as IL or intermediate language. Okay. So don't call it bytecode. And see, in Java, you're used to calling it what? Bytecode. But in .NET, don't call it bytecode, because bytecode is a very generic term. .NET's bytecode is called as intermediate language or IL, which is also referred to sometimes as MSIL. MSIL will be, any guesses? MS.
Microsoft Intermediate Language.
Correct. Microsoft Intermediate Language, which means the same thing as IL. There is no difference. Just another way of referring to it. Or it is sometimes even called as CIL or Common Intermediate Language. So all these terms mean exactly the same thing. So that's the format of your assembly. Your assembly is in IL format, right? The assembly itself might be either a DLL or an EXE. So you see these assemblies, .NET base classes, all of these are what? All of these are DLLs. But I'm saying your assembly could either be a DLL or an EXE. Now the difference between an EXE and a DLL is that an EXE also has an entry point defined. Right? It has an entry point defined. Entry point meaning what?
Starting of the program, where the program starts.
Where the program starts from. And typically that would be your main function. So every EXE compulsorily needs to have a main function, static void main function. But a DLL does not have an entry point defined. So it doesn't need a main function out there. So which means you can call the code on the EXE, but you cannot call the code on the DLL directly. You can't start off a DLL directly. DLL will just have the classes in there and you will call code from those classes, but that library cannot run directly. Are we clear on this? What's the difference between a EXE and a DLL? Okay. All right. Now, the format of an assembly is in IL format. But IL cannot be run directly on your machine. What runs on your machine is what is called as native code or machine code, another word of describing that. That is the code that will run on your machine. So to run your code, you have the CLR or the Common Language Runtime. Right. So the CLR is responsible for running your code. You can think of the CLR, if there was a question asked earlier, so you can think of this similar to your JVM, which is used to run your code. But here it's called as a Common Language Runtime. So why Common Language Runtime? Why is it called Common Language Runtime?
Because it runs on the bytecode, which is the common language for all the platforms.
No. Basically, because any language that yeah, you're partly right, but basically this is the same runtime for all .NET languages. So yes, all .NET languages get converted into IL, and then the CLR is exactly the same. It's not going to be different for different languages. All right. Now the CLR has a lot of functions that you could be using out here in the CLR. Right, a lot of things the CLR does. So let's see what are some of the things that happen in the CLR. One of the things that happens is JIT compilation or just-in-time compilation. So what is JIT compilation all about? What does this do for you?
It optimizes the code.
Yes, but what is JIT compilation actually? If you have to ask what is JIT compilation actually?
it stores the repetitive functionalities that are operating, and when they are called, so they get immediately called upon.
So basic thing, what does it do? It converts your IL into native code. JIT compilation, all of the things that you said also happen. But what does JIT compilation mean? JIT compilation means converting your intermediate language into native code. Native code is the one that is actually going to run on that machine. That's the machine code that you have out there. Okay. And the second term, just in time. Now this describes when does the compilation occur. So if I have a small code snippet for you out here. So first thing is JIT compilation is converting IL code to native code. And if you had a function like this, let's say you had main and which is calling different functions. When it runs, the first function that will run would be main. Now, at that time, only main is loaded into memory, converted from IL into native code and then run. When you call, let's say function 1 here, at this point of time, just in time when this is called, it actually goes and compiles, JIT compiles function 1 and converts it into equivalent machine code and then runs it. And follows the same process every time, the first time that you call a particular function. So function 2, function 3 being called again the first time. Again, JIT compilation happening here. But somebody again, mentioned that the second time that you call the function, let's say if you call the F1 again, now this has already been compiled, into native code and kept in memory. So the second call happens much quicker, where JIT compilation doesn't occur because it is already there, and then it goes and calls that again. So that is the second one here, which is second call or subsequent calls, which are much faster and much faster than the previous code. So that's how this would actually work out here. Okay. The JIT compilation is handled by a JIT compiler. So JIT compiler does JIT compilation, and this JIT compiler is also called as a jitter. Just the shorter name for a JIT compiler, a jitter. Okay. All right. JIT compilation is one of the functions of the CLI. Now, if you had to compare it with, let's say, C++, where the code that you ran, was not byte code. In C++, when you compile your code initially, when you compile your source code initially, you directly got, native code. So first question is, what are the advantage of having, this sort of two-step compilation? What benefit do you derive from that?
Speed.
Portability.
Sorry?
Portability.
First is portability. Your code now can run on different platforms because the conversion to that particular type of platform is at the time on when you're running the code, you know what you're running it on. So you get the benefit of firstly portability. Now, if you were to compare it with C++ code, where in C++ you convert it directly to machine code, and then you ran the machine code, you ran that native code. So there is no conversion required. Versus this approach, where it's a two-step compilation process. So initially you're compiling it to IL, and then when you run the code only, then it's compiling it to machine code. So which would be faster and why? What, in your opinion, what should work faster? The ones, just the direct running machine code, should that be faster, or the two-step process of first converting to IL and then only when you run it, convert it to machine code? Which, in your opinion, would work faster?
C++ code,
Sorry, C++ code.
direct compile code.
Directly, your machine language code that you're getting, which is running native code that is running directly. Right? That should work faster. Right? But we said that .NET code gives you better performance than previous code. And this works much faster than the previous code as well. So even though it's a two-step compilation process, why does this still work faster than the previous one? So now there are a couple of reasons to explain this. First reason is load times are faster. When you run your application in C++, supposing you had in that library, you had 1,000 functions. All 1,000 functions would be loaded into memory. Whereas here, what is happening? You're only loading which function to memory? Only the main function is being loaded into memory. So your load times are much faster. Secondly, there is an overhead of machine converting into machine code. There is an overhead. There's no doubt about that. But that overhead is very minuscule because it already is in IL format. So converting it to native code does not take a very big amount of time. So there is an overhead, but there is a slight overhead. But the benefit that you get is because you know on what type of platform or on what type of machine or what type of processor you're running it. And you can optimize it to run for that type of machine or that type of processor and that type of platform. So there's not just one jitter, there are multiple jitters out there. And based on what type of configuration you're running it on, the CLR will pick up one of the jitters and optimize code to run on that type of configuration. So the code that is emitted out is optimized code. And that is where you get the performance kick. Because that code is the one that is running faster than the non-optimized code. Are we clear on this? So even though it seems slower, it actually outperforms any other, not just its previous predecessors, but even its competitors. Even Java. I mean, .NET code works much faster than Java. And this is where you're getting the performance benefits. Are we clear on this? Now it becomes very easy to sort of get into an argument and I say this and you say this and we both have our own reasons for saying no, I think this will work faster, I think that will work faster. How do we conclusively prove it one way or the other? How do we definitely say that okay, yes, this is working faster? How can we be sure about that?
So
What would be the way of by doing some performance testing on it, by running similar code on all options and seeing which code works the best. So performance testing has conclusively proved that .NET code works much better than any other. Are we clear on this? All right. So this was one aspect of the CLR, which was JIT compilation. Besides this, CLR has many more functions. Let's look at some of them in one by one. One of the things that the CLR does is memory management. So memory management will deal with, when you run your application, loading the application to memory, right? Allocating memory for your objects as they are going along in your code, deciding where that object should be created, right? Whether on the heap, stack, all of this would be part of memory management, right? One aspect of memory management is garbage collection. Okay. So first thing is, what do you understand by garbage memory or garbage? What do you understand by this? What do you think is garbage memory?
reclaiming of processes at runtime automatically.
What is
Unused.
garbage memory? My question is, what is garbage memory? I'm not asking what is garbage collection. I'm asking what is garbage memory.
The object which is not used in a program, we can remove it using garbage collection.
Not
Object
use
which
meaning
do
what?
not have any reference.
Correct. That is the
Actually,
correct.
sir,
That is the
Unreferenced objects.
So that is the answer that I was looking for. Objects that are no longer being referenced. Such objects are referred to as garbage memory. For example, look at this code snippet. So if you look at this code snippet, first question, what is class 1 O? What is O out here?
Object reference.
Reference name.
So it's a reference of type class 1. O is not an object, it's a reference of type class 1. Object reference you said, but there was a pause between saying object and reference. So I almost said no. All right.
Yes.
So a reference to an object of type class 1. And the object is being created here when you do new class 1. So that's your object being created. New class 1 is your object, and O is just referring to it. O is just pointing to it. Correct? So at this point, O is pointing to this block of memory. At this point, when I said O is equal to null, O is no longer pointing to it. So now who's pointing to that block of memory of type new class 1? Earlier O was pointing. Now who's pointing to it if I said no? O is equal to null?
No one.
No one.
No.
So this is what you mean by unreferenced memory. So now that block of memory is not being referenced by anyone. And such a block could be referred to as garbage. Garbage memory. So garbage collection is the process of freeing this memory, which is no longer being referenced. And this is handled, or this is done by the garbage collector. So the garbage collector is responsible for freeing memory, which is handled by the CLR. Okay, it's handled by the CLR. Are we clear on this, everybody?
Yes, sir.
Okay.
Yes.
Okay. Now to understand how garbage collection runs, I'm going to take a parallel example. I'm going to take a slightly different example just to explain to you how this is working in memory. So, unfortunately, all of us right now are in different, cities, right? I'm in Mumbai. I don't know where you all are. I believe majority of you all will be in your hometown, right? So you're not really, we are not in the same center. But I would have liked it to be in the same center. Like if for example, we are at Sirak, Kharghar or Juhu or whatever, we'd have liked it to be in there. So let's assume for a moment if you're in Sirak, Kharghar. Okay. Now, I would have to physically come there to take a lecture, meet you all one by one, interact with you all, and I like that a lot. But one more interesting thing would have been that, in between our lectures, you would get a tea or coffee break. So when our lecture ends, you'd have a tea or coffee break. And, you could go and have your cup of tea or coffee. Right? Now, when you have the tea or coffee, there are two options. One is, of course, you have the disposable cups. But Sidak Kharghar, for example, doesn't have that disposable cup. It has that reusable cup where you can wash it and keep it back. Okay. So assume for a moment that the cup of tea or coffee that you're drinking is a block of memory. So I'm asking you to think of that as a block of memory. And what you are going to do is you're going to finish drinking that cup of tea or coffee and then in a reusable cup. So you need to now wash that cup. Now, two ways of washing the cup. One is you yourself have to go and wash the cup. So you finish your tea, coffee, then you go to the sink and you yourself wash it, and then you come back. But that would mean that if there are, assuming there are 120 of you all in one batch, and let's assume everybody had their cup of tea or coffee, there'll be 120 people queuing up to do what? To wash your cup and come back. And I generally give maybe a 15-minute break. So that 15 minutes may not be enough for you to do what? To have your cup of tea or coffee and to wash it and then to come back. So it will actually, be a little slower process out here. So to speed up things, CDAC Kharghar has appointed a teacup collector. Okay. Now, what is the job of the teacup collector? The job of the teacup collector is simple. He has to go and, collect all the cups that are no longer being used, and he has to wash them. Okay. Now, I'll give you a little scenario before I'm going to ask you a question based on this scenario. Let's assume that, you're not the only people at CDAC. There are other people at CDAC also. There are maybe there's another program, there's another, training going on. Maybe there are, the offices out there where software is being developed and all of that. The other teams sitting there. So you all are there, but there are other people also sitting out there. Now, everybody can pick up a cup of tea and go anywhere that they want to. Okay, so you could pick up a cup of tea and go back to your place where you're sitting in your, writing your code and whatnot. Not you, but the other guy who's sitting in the CDAC office. Right? So anybody can come in and take a cup of tea and go anywhere. Okay. Now the teacup collector has been told how to collect the cups, but he has been given this instruction. He has been told this, that if you get up from your seat and you want to go and collect the cups, you have to not go and collect only one cup and come back. You have to go and collect all the cups. All cups, what? Not if people are drinking tea, not those cups, but cups that are being used now. So he has to pick up all of that and come back. Okay, understood the scenario? What are the instructions given to him? Pick up?
Yes, sir.
Pick up what? All the
Those
cups and come back.
cups.
All the cups which are not being used, of course, and come back. Now, based on this scenario, my question to you is this. When should the teacup collector get up from his seat to go and pick up the cups? When should he go and pick it up?
After the tea break.
After the break.
Once the break is completed.
The
So I'm
time
not
is
saying yes or
scheduled.
no. I'm not saying yes or no. One second. I'm not saying yes or no. I would like to hear your responses. So I'll then comment on that later. Go ahead.
There is time schedule,
Person-
and he will come and collect after some time.
When
I'm not
person
saying yes or no.
tea,
As
when
per
person
his
finish tea.
as per his understanding, he'll wait for some minute and then he'll go and collect the cups which are empty or no longer in use. Because if he go at that time, it may be chances that some people wouldn't have completed it drinking the tea. So he'll wait for some time, and after certain duration, he'll go.
So I'm not saying yes or no. I'm just hearing your responses.
When
But any other responses?
when someone give a call for to collect.
I'm not saying yes or no. I'm just saying, okay, tell me what you feel. When should he get up?
Sir, he can do it periodically, means after some time.
When
Till
the
that
break is
break.
over.
So when there are no cups left.
the break ends.
Okay. So I've heard different responses. Let me summarize what I heard. So one thing that I've heard was somebody said right now, one of the last ones is after I call him, after, when he's called, okay, come and collect it. So now remember this, I finished drinking my cup of tea. Okay. And say, please come and collect my cup of tea. So he gets up from his place. He collects my cup. But what has he also been told?
Collect the other cups which are
Collect
not
all
being
the
used.
other cups.
Collect all the cups.
So he will go now in the entire office, wherever people are sitting, wherever there's a training going on, whether there is, a meeting going on or not. He'll go everywhere and say, cup do, chalo, khali cup do. And he'll come and pick it up and he'll come back. Now, is this a good way of doing things?
No, sir.
No, sir.
Imagine if every time you finish a cup, he's going and disturbing everybody. Good way of doing things? Yes, no?
No.
Obviously not.
No, sir.
Obviously not. Okay. The second response that I heard was after my tea break is over. That was one thing. The other one that I heard was, periodically, every certain amount of minutes or, whatever, hours, minutes, whatever the case might be. Now remember this, I'm not the only person in CDAC. So when my tea break gets over, only then will you go and pick it up? What if, I don't come only today. Today we don't have a lecture. Then should he not go and pick it up? Or if you are having a lecture here and there are other lectures going on also. So when our break is over, is it fair to go and disturb the other one also?
No, sir.
So that also is not an ideal situation. Or periodically. So let's say he's been told every half an hour come and take it. So let's say I'm having a 3-hour session. That means 5 times he's going to come in here in between. In the middle of my session to check what is he checking for? Are there any empty cups there or not? So these are not ideal situations.
So the number of cups are fixed in this case?
Yeah, a fixed number out there.
Okay.
There'll be a stack of cups that kept out there. No? There cannot be endless cups. So one of the answers that I heard towards the end was that when number of cups are less. Right? So imagine this. Let's assume right at the start of the day, there was a certain number of cups. I don't know how many. Let's say 500 cups were there. Right? Now, when should this guy get up from his place? When should he definitely get up from his place? When should he definitely get up? Definitely.
So when there is no cup left.
Right? So when there are not enough cups, now instead of saying when there are no cups left, maybe he should not wait till that last moment. Because for him to go and collect the cups and bring and wash them back and make it available again will take a little time. So maybe some limit, whatever. Now the number can vary, right? Let's say maybe if there are 500 cups, maybe when 100 cups are left, then he should go and pick it up. I don't know. I mean, that number is, you can fix it. That is up to you. But when that certain number is reached, whatever number fixed by you, that's when this guy should get up. Yes or no? Now, which would mean that at that point of time, he may come in once into class and come, but it is an unavoidable situation. Because if he doesn't come, then what is going to happen? There are not enough cups available in any case. Right? And remember, we are equating that cup of tea with what? With a block of memory. So yes, even if it means that, at that time he disturbs you, then that's okay. But that will happen very less compared to what other situations that you are telling me about. Other situations that you gave me, he's coming into my class more often. Instead, when can he come? When there are not enough cups available. And that will happen maybe once a day. I don't know how many times in a day it will happen. But definitely less than all the other options that you suggested earlier. Are we clear on this?
Yes, sir.
Yes, sir.
Yes, sir.
Now this same situation, now let's get back to our technical example of the garbage collection. So when will garbage collection happen? When will the CLR, remember the CLR is responsible for running the garbage collector. So when will the CLR run the garbage collector?
Like when we are low on available memory.
When you're low on available memory. Who decides this? Who decides this? When are we low on available memory? Who will decide this?
Operating system?
CLR. Memory management is an aspect of the CLR. So CLR will decide this. Yes or no? So now let's come back to the code that we are writing and tell me on which line of my code will the CLR run? Will the garbage collector run? Which line will cause the garbage collector to run?
O equals to null.
Yeah, correct. O is equal to null.
Yes,
That's
sir.
when the garbage collector will run.
Yes, sir.
You agree with him, everybody?
No.
After
sir.
that,
After
that.
the reference. No, that particular memory is just applicable for garbage collection, not garbage collection.
No,
is not-
my question, don't change my question. My question is, when will the garbage collector run in this block of code? I'm not asking you the question that you just said. No, this is the other question. Answer my question. When will the garbage collector run in this block of code?
We cannot say.
When O is equal to null.
Okay. So let's go back to what we just spoke about for the last 10 minutes.
New memory allotment.
No, let's understand what we said in the last 10 minutes. Please understand. You all have heard me, but you all are not understanding this. What did we say? When does the GC run? When does the garbage collector run? When memory is low. Correct or no?
Yes, sir.
Yes, sir.
So which line of code of mine is causing memory to become low? How do you know that on this line of code that memory is going to go low, so low that there's going to be not enough memory available? Do we have any line out here which is doing that?
At the time of
New
object.
keyword.
At the time of object creation.
So you are trying to say that if you create an object of that class 1 class, you're going to cause your system to crash? That not enough memory.
So we are not.
Is that what you're telling me?
We are not sure at which line it will happen.
Yeah,
We can't say.
correct. That is the correct answer. Somebody said O is equal to new class 1. Are you saying that new class 1 is going to take so much memory that your system is going to go low on resources? Are you sure about that? Then you need to examine what you're doing in class 1. So the correct answer is we don't know. No? None of these lines is going to cause the garbage collector to run explicitly. We don't know. When is the GC going to run? Are you agreeing with this statement that the GC will run when system is low on resources?
Yes,
Yes, sir.
Yes, sir.
So which line is causing it to go low on resources?
it's uncertain.
No, we don't know what line is going to cause that. So is there any line in my code which is causing the GC to run? No.
No, sir.
No, sir.
So we
No,
can
sir.
only call it, but we cannot sure ki it will collect or not.
No. Am I calling it anywhere? You're
No,
again
sir.
changing the problem statement. I'm asking you, who are you? You are telling me I like to play cricket. Answer my question. Don't change the parameters of my question. I'm asking you X, you're answering Y. Looking London, hitting Tokyo. I'm asking you specific questions. Which line of code is going to cause the garbage collector to run? And the answer is we don't know which line will cause it to run. We are not certain whether it will run, not run. We don't know. Because your code is not controlling the garbage collector. Who's controlling the garbage collector?
CLR.
CLR.
DLR. Are we clear on this, everybody?
Yes, sir.
Yes, sir.
Yes,
Yes
sir.
or no? Okay. So let's take this little further. Okay. Now, please answer my specific questions. If I'm asking you, what is the day today? Don't tell me it is cold. Are we clear on this?
Yes, sir. Yes, sir.
Okay. So my first question to you is, what is a constructor? What is a constructor? What is a constructor?
Constructor is a method which is having no return type and used to initialize object.
That is not the answer. The second part is not an answer to me. Have I asked you what is it used for?
No, sir.
What is a constructor? Answer to the point.
It
A
is a
constructor,
method.
first part was correct. A constructor is a method,
Without a
right?
return type.
It doesn't have a return type and generally is the same name as that of the class, generally. Right? So, okay, fair enough. I'll accept that part. Second part. What is the constructor used for?
Initialize object.
Which objects? Your own object that is creating, it is used to, initialize this object. What is it used for? To initialize what? Any members, any
Section
data
of
members
class.
that you might be using in your object. To whatever data members in your class you're having out there, it is used to initialize those data members. Correct? Okay.
Yes.
Next question. What is a destructor? What is a destructor?
So
Again,
that releases the resources after
now
performance.
you're telling me what does it do? I'm asking you, what is a destructor? What is a destructor? Again, what?
It is a
Delete
method,
the
sir.
objects when
The
and no
destructor
use.
is a method again.
Yes, sir.
Okay, which generally is tilde and the class name is what you learned. That's your method. So it's a special method. Okay. Next part. What do you do in a destructor? Or before we do that, when is the destructor called? When is the destructor called?
Execution.
Right? When is the destructor called?
At the end of the program.
Nahi re baba.
When object is destroyed.
Correct. When whatever memory you allocated, when is the constructor called? When you allocate memory for an object of your class, that's when the constructor is called. When is the destructor called? When the block of memory that you allocated for your object, when that is being released, that's when the destructor is called. What do you do in the destructor? Next question. What do you do in the destructor?
Release dynamically allocated memory.
Very good. Very good. So in your object, if you are holding on to other resources, the other resource could be either you holding on to other memory, one possibility, or maybe let's say you have some other resource, like let's say a file. So you opened a file somewhere in your code and you want to now close that file. Or if let's say you opened a connection to the database and you want to close that connection. So any resources that you're holding, he said memory, I'm going to extend that term and say any resource. Could be memory, could be what? A file, could be a database, any other resource. If you're holding on to any resources in your code, before your object is being destroyed, you're releasing those resources. That is the code that you write. Are we clear on this, everybody?
Yes.
And when does the destructor get called? When does the destructor get called? When your object that you created, when that object is releasing its memory. That's when the destructor is getting called. Are we clear on this, everybody?
Yes, sir.
Okay. Now my next question to you is, again, if you look at these lines of code, can you tell me where will the destructor get called?
O equals to null.
Sorry?
Align O equals to null.
Okay. I'm not saying yes or no. If others agree or disagree with him, then if you agree, then keep quiet. But if you disagree with him, give him a different answer. He said O is equal to them. I'm asking you on these lines of code, where will the destructor be called? He's saying O is equal to null.
We not called it here.
Where will it get called? Yes. Which line will call the destructor?
O equals to null.
So that is the same answer that he gave. Anybody else has a different answer?
It might be uncertain.
Why might be uncertain?
Because we don't know where it is going.
No, why might? There's a difference between saying, I ask you who's answering this?
Sir, it's Ankit.
Ankit. So if I ask you, Ankit, what is your name? Are you going to tell me it might be Ankit?
No, sir.
So then tell me with conviction, what is your answer?
Sir, it is uncertain.
Okay. So why is it uncertain?
Because we don't know when the garbage collection will release the memory.
Correct. Well said. So what did we just talk about for the last 15 minutes? We said that the unreferenced objects are not freed immediately. They're freed when is memory being released? When the GC runs, when the garbage collector runs. When does the destructor get called? When memory is released. When does the memory get released? When the GC runs. When does the GC run? When does the GC run?
Uncertain, sir.
Uncertain. Uncertain. Controlled by the CLR when it memory goes low. So when will my destructor run?
Uncertain.
Uncertain. Not on O is equal to none.
Hello, sir.
Yes.
Sir, if when we write O equals to null, if our memory is not freed, so why after that line we are not able to access that object?
Because you're not accessing it through O, no? How it's unreferenced. How are you accessing that object? O is no longer pointing to it, but that object in memory, there are two things, no? O and the object in memory. Are you
Yes, sir.
getting the difference? So
Yes,
O
sir.
is
Yes,
not
sir.
pointing to anything, but that object is still there in memory somewhere, which is not being referenced.
Okay, sir.
Try
Got
and
it.
understand the difference between the reference and the object. Yeah. So are we clear on what we are trying to say? We are saying that we are not sure when my garbage collector will run, and the memory will be released when the GC runs, and the destructor will be called when the memory is released. So it boils down to what? I don't know when my destructor will run. Understood this, everybody? Yes, or
sir.
no?
Yes, sir.
Yes,
So
sir.
my next question to you is, should we then write any code in the destructor? Should we then write any code in the destructor?
No, sir.
Why not? Why
Sir,
not?
because we are uncertain when it will.
Of what? Of when it will run. Are we clear on this? Now this concept is called as non-deterministic finalization. What do I mean by non-deterministic finalization? What does that mean? What does the word non-deterministic mean?
We could not determine.
We don't know when it will happen. And finalization it deals with the process of releasing memory for that object once you don't need it. So in .NET, you're using non-deterministic finalization, right? And therefore, you should not write any code in a destructor. You should not. Can you write code in a destructor? Can you?
Yes, you can. We
Can
can.
you?
Yes.
Can you? Should you?
No.
No.
No, sir.
If you're on top of the 25th floor of a building, can you jump off the building?
Yes.
Yes.
Can you?
Yes.
Yes,
Should
sir.
you?
No.
No, sir.
Definitely not. And especially not after my .NET lecture. They'll ask me what did you say in the .NET lecture? Right? Don't ever jump off. But do you understand the difference between can and should? Can we write code in a destructor? Yes, we can. Should we be doing that?
No, sir.
No. Don't ever write code in a destructor. Are we clear on this? Then what should we do instead? What should we do instead? If we should not write code in a destructor, what does .NET suggest to you instead? So what .NET says is that you should write code in a method called dispose, which is part of an interface called iDisposable. So they ask you to do what? Implement the iDisposable interface. And this iDisposable interface has a method called dispose, and it says write code in there. Are we clear on this? Instead of doing what? Instead of
Writing code in destructor.
instead of writing code in the destructor. Now, why iDisposable? What does the dispose method look like? How does it work? All of these questions we'll answer when we are writing code, not at this stage. Are we clear on this? At this stage, I'm only saying what? Do not ever use a destructor. Okay. Clear on this?
Yeah.
But then in what situation we should write code in a destructor? In what situation should we write code in a destructor? Because there is a destructor in .NET. So can we write, when should we write code in a destructor? then in that case?
When we are certain that at this point the memory shall be released.
Answer is a trick question.
When you want to trace when the destruction is
It's a
done.
trick question.
We don't
The
write code.
answer is never.
Never.
Just because I asked you the question in a nice way does not mean you change your answer. Are we clear on this, everybody?
Yes.
When I asked you nicely if I asked you, no, but just tell me that some situation might be there when you write code in Instructor. Think an answer, when can it be? You don't change your answer. You've just been screaming your lungs out saying that do not jump on the top of the building. Do not do that. So when you want to write code in Instructor, it's akin to, it is similar to jumping off the building. Don't do that. Can you do that? Can you do that? You can
Yes,
do
sir.
that. Should you do that? Never. Are we clear on this, everybody?
Yes, sir.
So that's your garbage collection in .NET. Okay. All right. To do this for you to do, read up on generations in garbage collection. Read up on the concept of generations. What are generation 0, generation 1, generation 2? Read up on generations in garbage collection. All right. I'll ask you questions on this tomorrow. So read up on that. Okay. All right. Moving on. Let's look at the other features of the CLR, other functions of the CLR. One of the functions it also does is app domain management. Now, this is a feature that is available in .NET Framework, but not in .NET Core. So we'll, when we talk about what is .NET Core, we'll be seeing that later. But I put an asterisk next to this, saying that this is only available with .NET Framework. .NET Core does not support app domains. So let's try and understand what are app domains in .NET Framework. So normally when you run an application, whenever you run an application, every application starts off in a different process. Okay. Now, the process space allocated for that application is a lot more than what the application needs. Okay. And if you launch multiple applications, obviously you're launching multiple processes. At some point, you will run out of process space. You'll find that it does not give you enough, memory. There's not enough memory to start off a new application. So to try to optimize on that, an attempt was made where you could now run more than one application in the same process. What will be the advantage of doing so? What will be the advantage of trying to run multiple applications in the same process? Like this here on the third one on the right. What advantage do you see in doing this?
Optimization in the process memory allocation.
Correct. So you're trying to reduce the number of processes that are starting off so that you can try and optimize on memory. Now this approach worked. We are talking about this is before .NET. This approach worked, but it was highly unstable. Because if one application crashed, it also brought down all the other applications that were running in the same process. Okay. So it worked, but it was unstable. Now, let's see what happened in the .NET framework. In the .NET framework, when you ran an application, when you start an application, the application runs within what is known as an app domain, application domain or an app domain. So what is an app domain? An app domain is an area within the process in which the application runs. So it restricts the application to its own app domain only. All right. Are we clear on this? What is an abdomen? An abdomen is an area within the process in which the application runs. It's only restricted to its own abdomen. Now, if you try doing the same thing again, if you try in one process to run multiple applications, each application will run within what? Within what will it run?
Its own abdomen.
Its own abdomen. So what is the advantage now in this approach? What do you see compared to the previous one?
So if one crash, other is not affected.
Correct. Even if one crashes, even something happens to one, the other one is not affected. Other applications can continue to work because they're running in a separate abdomen. So your applications now could be launched in multiple applications, could be launched in one process without them being unstable. And this feature was used a lot with, web servers, where if you had multiple websites, instead of running them as separate processes, all of them will run in a single process, but each website will run as a separate application in a separate abdomen. Therefore, all of them will be stable. And you can optimize on process base. So this feature is used a lot in web-based applications. All right. Are we clear on this, everybody?
Yes, sir.
Okay. Now, you all have completed your operating system module, or it happens after .NET?
Yeah, done, sir. It was the first module.
Done. Okay. So far, have you heard the term process in operating systems? Have you heard that term? You know what's a process, right?
Yes, sir.
Yes or no?
Yes, sir. We know.
Okay. Have you all heard of an application domain before this?
No,
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 sir.
sir.
No, sir.
No, sir.
So why are you hearing about it for the first time? Because the abdomen management is something that is handled by the CLR. This is not something that has been done by the operating system. This is CLR specific. So management of abdomens is another function of the CLR. Are we clear on this?
Yes, sir.
All right. Okay. Let's take this further. Let's see some more features of the CLR. One more function of the CLR is CLS, or Common Language Specification. So what is CLS, or Common Language Specification? This deals with running, if you're having multiple languages. Now, each language would have its own set of rules. So if you try to now run all these languages together in .NET, there will be a disaster, because something might be allowed in one language which will be contradictory to the other language. Okay. Now, what .NET has specified is a common set of rules. CLS is nothing else but a common set of rules that is applicable to all .NET languages. So all .NET languages must follow some common rules, and these rules are given in CLS. Now, while running the code, it checks for, is it following the CLS rules or not? So if it is following the CLS rules, then no problem. If it is not following the CLS rules, then it will give you an exception while trying to run the code, saying that this code is not CLS compliant. Are we clear on this, everybody? So CLS is nothing else but a common set of rules that all .NET languages must follow. Okay. Questions, if any? All right. The next feature that we're going to talk about is a common type system.
So regarding this language specification, you'll be going in depth later, or this is the whole?
No, I'm not going to go into that.
Just can you once again repeat that?
I'm saying it's a common set of rules that all .NET languages must follow. I'm only going to be talking about CLR and C#. I'm not going to be talking about other languages here. Okay.
Sure, sir.
So can you give an example of that rule?
Okay, for example, one of the CLS features is that all .NET languages must have single inheritance. Okay, only single inheritance. It does not support multiple inheritance. So now certain languages allow multiple inheritance also, like, C++ allows multiple inheritance. So there is a language in .NET called managed C++. So managed C++ is the C++ equivalent in .NET. But even though it allows multiple inheritance, because multiple inheritance is not a CLS feature, when you try to compile the code, it gives you an error saying that this feature is not allowed in .NET. So then you have to say that this code will not be run by the CLR. You can mark that code as what is known as no GC code and say that this code should not be run by the CLR. So it will run outside the CLR and that will not be considered a .NET code. So that is an example of a CLS feature, for example. Understood?
Yes, sir. But if it is running outside CLS code, will it run, or we have to add some?
It will not run. It will require a different runtime. It is not .NET code. So you can write such code, but will not be considered as .NET code.
Okay, sir.
Would not be able to use the .NET features and would not run by the CLR. Okay. You can only run in .NET the code that is conforming to the CLS specification. All right.
Yes, sir.
You can have code that runs outside .NET also, which is not .NET code, which is running outside .NET. So that would be the type of code that you are creating out there.
So it won't have the features of
None of the features. No garbage collection, no memory management, no JIT compilation, no app domain management, nothing. Will not allow you to run that in CLR. Okay.
Yes.
Becomes non.NET code. All right. Another feature that we're going to talk about here is the common type system, or CTS. So again, I'm going to take up a small code example to show you what CTS does. All right. So let's say this code was pre.NET. Right. And you could write code in, for example, VB6, or you can write code in VC++. So let's say this was VB6 code. VB6, remember we said this ran before .NET, and let's say this was VC++ code. Right. Let me just get that code a little bigger. Let's say this is what we had. Okay. Now, what I'm trying to do is I'm trying to write a function in VC++. I'm calling the function as X, but I'm trying to call that function from VB6. And I'm saying I is equal to X of I. And this could be done. I mean, you can write code like this. So you can write code in one language and you could have called it in the other language. Compiled code, of course. Now, if you tried doing this, when you tried calling this, this would give you an error. Okay. So why does this give you an error? Why does this code that you've written here give you an error? The reason for that is when you declare an int in VC++, this int takes a 4-byte value. Right? Takes a 4-byte value. But if you define an integer in VB6, this takes a 2-byte value. And if you're trying to call code between languages, if the data types are not the same, it causes a problem. Okay. Now imagine having to deal with data types from 50 different .NET languages, 50 plus different .NET languages. would be I mean, you'll go crazy trying to figure it out. 50 different .NET languages, each having their own data types, would cause a big problem. Agree? So if you do this in .NET, how does .NET handle this situation? Let's say this was C# code. And if let's say this was VB.NET code. Okay, what if you're doing this now in VB.NET? So when you use a data type in a particular language, what it does is it converts it to what is known as a CTS type. CTS here is common type system. So for example, if you're writing an int in C#, this int in C# is being converted to system.int32. So what is now int now? Int is what is a C# data type. But int32 is the .NET CTS type. And when you write code like int a, compiler is internally converting it to what? int32a. Right? Similarly, if you wrote code as dim I as integer in VB.NET, this also is being converted to system.int32. So what are we using here? We are using exactly the same data types. Even though you're using different languages, your data types now are exactly the same. And which is why it allows you to call code across languages without any problem. Understood this, everybody? Questions, if any?
So are we going to code in different languages here?
I'll just need about a couple of years of your time, and we can do that.
So not in our module.
No, we can do that. No problem. Okay. 2 years, 3 years. You give me. We
So
learn
here
C#
we are.
first. C# first we'll learn. Then we'll learn VB.NET. Then we'll learn Fortran.NET, COBOL.NET. Then we'll learn Python.NET. All right. We'll learn them each one. 2 years should be enough. 50 languages. But by then they might come with other languages also. And yeah, we'll do that. No problem.
Yes, I'll be looking for that.
So we'll be focusing on C#, right?
Which is what we've been saying multiple times so far.
Yes.
Okay. Yeah, so jokes apart, no, we're not going to do any other language. You're going to focus on C#. That is the most popular language used in .NET. And also because you all have a C++ background, so it's going to be easier for you to learn that language. Imagine having to write dim I as integer, having to learn a new data type. That will take you much more effort. Okay. All right. Okay, by the way, what do you think system.int32? How many bytes would this be? Any guesses?
4.
4. Why 4? 32 bits or 4 bytes. Okay. So that's your common type system. So whenever you're running some code, it will first check for what? Are the data types that you're using, are they using the CTS types or not? All language will use the same thing. It will check. If it is not using that, it will say, sorry, I cannot run your code. That's what the CLR would do. All right. Other functions of the CLR. Thread management, managing threads. When you run your code and you're, creating threads, all of this thread management is also done by the CLR. We have an extended session on thread management. So, we'll talk about threads at that time. At this point, I don't want to get into thread management. Security management, security features, making sure that when you're running your code, do you have the requisite permissions to run or not? All of this is handled by the CLR. So again, would come in much later, not right now. Debugging an application. So when you're running your code, for example, inserting breakpoints into your code, making wait out there, going one line at a time. So all of this has to do with running your code. All of this is a function of the CLR. right? Exception handling. What is exception handling here? If an unhandled exception occurs, how does your code react? How does it, there's a try catch, for example, how does it go from the try, it jumps into the catch, goes to the finally, all the running of that code. Try catch finally here would be very similar to what you've done in Java before. So all the code that you're writing with exception handling is all handled by the CLR. So these are, all the things that you need to know about when you're running your code. All of these options are being handled by the CLR. Are we clear on this, everybody? Any questions, any doubts on any of this so far? All right. So now I have a question for you. Right. Let's assume I have some code with me. So I've written my source code. And after writing my source code, I have, compiled it. I have made an assembly. So assembly is now containing your, code that is a, IL format that can be run on your system or whatever. So I have this on my system. I've started by writing C# code. I have compiled it. I've got an assembly. Now I want to run the assembly on your system. I'll repeat. My assembly, I want to run it on your system. So what is it that your system would need for me to run my code?
CLR.
Okay, I'm not saying yes or no. I'm just listening to answers. So one answer I've heard is CLR. Anything else? Anything else required?
Runtime environment.
Which is the CLR?
.NET framework.
I don't know. I don't understand what is the .NET framework. I'm asking you, where do you see the .NET framework here? I'm asking a very basic question. I've got an assembly. My assembly I'm copying onto your machine. What does your machine need to have?
IL.
IL is the format of code. IL is not anything. It's a format of a code. It's a type of code. So my code is in IL format. What does it require for me to run on your system?
CLR.
One thing I've heard is a CLR. Anything else you think would be required?
.NET base class libraries.
Right. Remember, all my source code that I'm writing is using code from where? From .NET base class libraries. So if I'm going to refer to those libraries, your system will also need to have what? The base class libraries. Plus, it will need to have the CLR. Agree? CLR, of course, will be responsible for running your code. So you'll need both of these. Are we clear on this? And if you have both of these on your system, then my code can run on your system. Now, somebody in between mentioned the .NET framework. So when you install the .NET framework, what do you get? The .NET framework, of course, sits on the top of your operating system. So when you install the .NET framework, you get the base class libraries plus the CLR, plus you will also get certain utilities that you can have with the .NET framework. So what sort of utilities now? These are all command line utilities. One example of a utility could be the compiler that you're using, right? And we'll be going through other utilities as we see, as we start coding, we'll be seeing other command line utilities that we have. But one that you can immediately identify with probably what would be the compiler. So the .NET framework, this plus BCL plus CLR plus utilities is what you get when you install the .NET framework. Are we clear on this, everyone?
Yes, sir.
But out of the .NET framework, what specifically do I need to run my code? I will need what? On your system, I'll need base class libraries plus what? Plus plus
CLR.
the
CLR.
CLR. I don't need the utilities to run your code. But when you install the .NET framework, you get those utilities also. So somebody said that, yes, my code will run on the other machine if I have the .NET framework, which is the correct answer. But of this, what do I need? What specific components do I need to run my code are only these two. Are you getting the difference between the two slight new? .NET framework consists of everything. Right? See, when Ram told Hanuman, ki, go get the Sanjeevani. Or not Ram told Hanuman, sorry. Who told Hanuman to get the Sanjeevani?
Ram.
The Jamban or
Jambuan.
Yeah, so you all know your history better. Okay, I don't. Somebody told Hanuman, go get the Sanjeevani. So Hanuman got the whole mountain. No? But what did he require? He required only the Sanjeevani. He required only this. When you say .NET framework, it also consists of other things out. Are you clear on this? But yes, that answer is also correct. The .NET framework, when you install, you're getting everything. And then that is what you need to run it on your other machine. Understood? Okay. Second question to you. So again, now I've done what? I've got my source code. I've compiled my source code and I've got my assembly. Now I want to copy my assembly again onto your machine and run it on your machine. But your machine is a Linux machine. Your machine is a Linux machine. So what would I need on your machine for my code to run on your machine? Yes.
BCL and CLR.
Can I use the same BCL and CLR that I've used? Mine is a Windows machine. Can I use the same BCL and CLR that I have on my machine?
sir.
Can I use that on your machine?
No, sir, different.
Right. So when I need to run the code on your machine, I will need to make sure that there is a BCL for Linux and there is a CLR for Linux to run it on your machine. If I have that, I'll be able to run my code. So essentially, it's like saying somebody, if you're saying, okay, if you're talking about the whole mountain, then a .NET framework for Linux is what I'll need to run it on the other machine, which includes a BCL for Linux and a CLR for Linux. Now the question is there any such .NET framework available for Linux? The answer is yes. It is called Mono. Right? So what is Mono? Is nothing else but a .NET framework for Linux. Okay. But this .NET framework for Linux, Mono, was not created by Microsoft. Microsoft has not created Mono. This is a open source initiative created by third party. I mean, other people, programmers from all over the world have contributed and created Mono. Not Microsoft. Microsoft didn't come out with Mono. Microsoft said, I will give you a framework for Windows only. Why are they saying that? Why are they saying I'll give only for Windows, not for other operating systems? Why are they saying that?
Promote Windows.
Of course, marketing decision. They are saying, we know .NET is better. So if you want to use .NET, you have to make sure what you buy Windows. Right? So now, who came up with Mono? Mono was started by other people who are anti-Microsoft. They're saying, oh, Microsoft is not giving you a framework for Linux. We will give you a framework for Linux. Are we clear on this? So Mono doesn't.
Application
Say that again. Was that directed to me? I couldn't hear you. Or maybe it was just... Okay. Okay. So the asterisk that I'm talking about there. One of the earlier things I said, my code will work on multiple platforms. So when will .NET code work on multiple platforms? It will work on multiple platforms if there is a framework for that platform. If there's a .NET framework for that other platform. Now, Microsoft is not giving you frameworks for other platforms. So .NET framework is only, what does this only work for? Code for this works only for what? For Windows. If you have Mono, then your code will work on Linux. So this is when they first came up with the .NET framework. Are we clear on this? Yes or no? Understood what this is happening?
Yes, sir.
Yes, sir.
Now, the .NET framework was launched in the year about 2001 or so. And for a very long time, Microsoft only allowed code to run on Windows. And Mono, of course, was an external thing, it was not from Microsoft. But they found that a lot of people are not using .NET because of this reason. Because your code now is only working on what? On Windows. Whereas, if you look at something like Java, Java code works on all platforms. So people are preferring to work with Java because code is not working on other platforms. .NET framework code. So Microsoft had a change of strategy. They said now we will come up with a platform which is like .NET, which is like .NET framework. But in this platform, our code will work on all platforms. And that is what .NET Core is all about. So .NET Core is what? Is .NET code that works on all platforms. Right? So .NET Core is .NET code that works on all platforms. Are you clear on this? So this is a change in thinking, change in marketing, change in strategy. And this, they started working on the .NET Core, around the year 2010 or so. Now, as of today, you have two variations. You have .NET Framework and .NET Core. .NET Core is allowing you to work on everything. But .NET Framework is only allowing you to work on what? On
Windows.
Windows. And all these application types that I showed you on top, all of them are there in .NET Framework, but only some of them are there in .NET Core. Are we clear on this, everybody? So all variations of everything is there in Framework, .NET Framework. But .NET Core only has certain aspects out here. It doesn't have all the aspects. Clear on this, everybody? Yes?
Yes, sir.
All right. So let's explore a little further on what this is. All right. So this is what we said earlier. What are the .NET framework, which consists of what? .NET base classes plus CLR plus utilities. What would you need to run code on your other platforms? You need a framework on the other platforms. All right. So just talking about this. .NET framework is used for Windows platform only. Mono is used for Linux. .NET Core is used for all platforms. And one more here, Xamarin. I didn't mention Xamarin. So Xamarin is used for mobile platforms. All right. So these are the broad programming categories that you would be using out here. Okay. Clear on this?
Yes, sir.
Yes, sir.
Sir,
So now let's, yes, sorry.
Sir, which framework we use on
We're using
Mac OS?
Core.
Okay, sir.
Okay. The .NET Core key features First thing is it is open source. So, freely available. Anybody can go and see the code in there, available on Git. You can go and see what is happening out there. Secondly, cross-platform. We just mentioned that, code will work on other operating systems as well. Thirdly, lightweight. So lightweight and extensible, I'll talk about together. So in .NET framework, for example, if I got .NET framework application, you need to have what? You need to have the entire framework installed. The entire framework is very big. It's huge. So you need to pre-install it on the target machine. But with .NET Core, what they do is they say we will include only the libraries that you need. We'll only include the libraries that you need. So we'll only have certain files. And they have rewritten the .NET framework. They have rewritten it to make it open source. All right, they have made and cross-platform. Not open source, actually cross-platform. They have rewritten it. So the libraries have been rewritten and they have made smaller, lightweight libraries. And now you only include the ones that you want. So instead of taking one large library which has everything in it, you take what? Smaller parts out there. You just say, okay, I want this, and you include that. And while installing the files, you only need to install the files that you need, not all the files. Are we clear on this? Also, they're saying we are trying to make this extensible. So which means that now, instead of only having software coming in from Microsoft, you have a lot of third-party tools available. And you can now plug and play. So you can use that tool in here. Also because it is open source now, more and more people are doing that now. Developing applications for that. So this is what the difference is between .NET Framework and .NET Core. Are we clear on this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So they have rewritten the whole thing. .NET Core is a rewritten library. They have made it now working on all platforms. All right. Now let's quickly look at something. This you don't have to learn this. This is for you to understand what is happening. So let's look at the first, the part on top, the green part on top. So that has to do with .NET Framework. So .NET Framework, the first version came out in Feb 2002. Before that, the betas came out in 2000, 2001. We were working with the betas on that. So for a long time, we were working on the betas, right? And we did a lot of development with the betas itself. But the framework was officially launched in Feb 2002. And then it started different versions. So look at that now. .NET Framework 2 came out in October 2005. Framework 3 came out in 2006. 3.5 came out in 2007. Framework 4 came out in 2010. And then now in between there, I have not put down all the things, but in between, like there was a 1.1 or a 3.1, 3.2, 3.3, 3.5. There was a 4, 4.1, 4.2, 4.3, 4.5, 4.6, 4.7, 4.8. So all of those minor versions also are there in between. I have not put all of that. Okay. So look at this timeline. Look at the timeline that we had here. And around 2010, 2011, I said that they had a change of heart and they started working on .NET Core. So .NET Core, first the betas came out and then the .NET Core 1 was officially released in June 2016. So officially, if you look at the dates from 2002 to 2016, what are we only working on? Only working on .NET Framework, which will only work for what?
Windows.
Only work for Windows. But the real, cross-platform thing has started from just 5-6 years back, 2016 onwards, June 2016 onwards. So that's when yes.
Sir, do this cross-platform frameworks contains all the .NET features that are available on this version?
No.
Like the Xamarin contains all the
No.
features
I'll tell you that. Let me explain to you that. I'm coming to that in a later this thing. But short answer is no. They're not the same everywhere. Okay. Now, if you look at .NET Core 1 2016, when .NET Core 1 was out, what was the .NET framework that was out? 4 point something.
4.8.
4 point something, not 4.8, but 4 point something, 4.2, 3, 4, whatever was out at that time. Now, in the meanwhile, 2017, you now came up with .NET Core 2. So now you're having two parallel tracks. You're having .NET Framework also happening and you're having .NET Core also happening. .NET 3 came out in September 2013. So which means now us developers are working with having to deal with different things now. You need to know what is happening in .NET Framework differently. You're having to know what's happening in .NET Core differently. Now, to confuse you even further, I've not put that down here. ASP.NET also had its own versions. So ASP.NET also has 1, 2, 3, 4, so on and so forth. And ASP.NET Core also had its own versions. And there was something called ASP.NET MVC, which had its own versions. And C# had its own versions. So we were going crazy trying to keep track of what is the version number and what feature does it support. Because there are so many variations of the similar things going on out here. So they took a decision, Microsoft took a decision saying that going forward, we are not going to have more work going on .NET Framework. So after this, we will only support what?
Core.
After this,
.NET Core.
.NET Core, right? So we will support .NET Framework only for Windows, but new development will not happen in .NET Framework. All new development will happen now in .NET Core, because in .NET Core, you can also create applications for Windows. Are we clear on this, everybody?
Yes, sir.
So around that time, when they took the decision, .NET Core 3 was released. Now, when they wanted to release the new feature of .NET 3, they said, we will not release 4. We will not call it .NET 4. Because there is already a .NET Framework 4 and people are already very, very confused with all these version numbers. So they said, we will not come up with .NET Core 4. Instead, they skipped a version. And they said, after 3, we'll come up with 5. After 3, we'll come up with 5 to avoid confusion. But this new thing, we will not call .NET Core. We will only call it .NET. So why do you think they're not calling it .NET Core now? And they're only calling it .NET now? Yes. What is the reason for them saying we will not, after .NET Core 3, we'll come up with .NET Core 5. Why skip a version? Why skip a version?
To avoid confusion.
To avoid confusion with .NET Framework. And why call it only .NET and not call it .NET Core? Why .NET Core 5 is actually now being called as .NET 5. So why do that?
It might have both framework and core as well.
Correct. Because we are now not going to have both. We're going to have only one. Framework is over. We're not going to do .NET 5, .NET Framework 5. We're not going to come up with. So we'll only have it as .NET 5. But .NET 5 is actually what? Is .NET Core 5. Are we clear on this?
Yes, sir.
Okay. So now November 2020, they have come up with 5. 6 came up in November 2021. 7 has just been released a couple of months back in November 22. Are we clear on this, everybody? And 8, of course, was proposed in November 23. Are we clear on this out here?
Yes,
When
sir.
did your CDAC batch start?
September 22.
September 22.
At that time, what was the last version release?
6.
6. .NET 6.
.NET 6. So that's what we have in your course. Are we clear on this, everybody?
Yes, sir.
Okay. All right. Any questions about any of this so far?
So we were asked to install Microsoft Virtual 2019.
No, who asked you to do that?
Faculty.
I have, who is it, Aniket?
Yes, sir.
Aniket, I have given you a message on my lab. Is Aniket there?
Yes, sir.
Aniket, I have sent you a message on WhatsApp asking them what software to install.
I told everyone, sir, that
It was informed. It was informed.
Yes, sir, it was in.
Yes, sir.
So
We
then
installed
please,
community version 22.
so
You
don't please make statements like this that we were told to do this. Don't create confusion. The person who said that it has explicitly been told to you what software you need. Do not create confusion. Please install the correct version of the software today. And if you don't know what it is, please reach out to Aniket individually and Aniket will guide you correctly. All right. So anyway, I'm ending the session here. I'm out of time for this session. I'm not done with this explanation. There are a few more things that I want to talk about, but we'll continue with that in the second half. All right. So enjoy your lunch and see you post lunch. Bye for now.